Welcome to EDU World Space.
Hi, everybody. So we're looking at problem 13 in chapter 7, Introduction to Modern Astrophysics. So this question is asking us, estimate the fractional decrease in the brightness of the star, assuming that you observe the flat disk of a constant flux with a temperature of T, I believe that's C5777K, 5,777 kelvins. Hint, it says neglect Jupiter's contribution. Okay, so we're going to use the luminosity of the sun equation. Luminosity, and we get beta, which is Stefan Boltzmann constant, times 4 pi r of the sun. We're going to use circle is the radius of the sun, squared. Can't forget that. And T is effective temperature, and I believe that is 2 to the 4th. Okay, let's see. And okay, so we can assume the sun to be a flat disk with constant flux. And so when we do this, we end up with a delta L. And we also have to decrease luminosity due to Jupiter's blocking. It's equal to the luminosity area covered by Jupiter. Okay. Oh my gosh. 4 pi r, and we gotta do the radius of J, which is Jupiter squared minus T to the 4. Okay. So now we got to do the brightness of the sun, which is F, circle, or you don't have to add a little circle there. And then we have luminosity of the sun over 4 pi r squared. R is the distance to the sun from the planet. And if we introduce the above here, you'll get it looking kind of like this over 4 pi r squared. Okay, and reality, we can also do the delta of here, and we're just gonna write it out so it's just easier for us to just do this instead of constantly. And don't simplify anything yet. I promise that sometimes when you simplify, it makes it a lot worse than what it is. Okay, so we can simplify it. Let's just simplify it, okay? So when we do that, we get r squared t to the 4th over r squared rj t to the 4th r squared. Okay, so now we're gonna like just actually set these up. So we're gonna put delta f naught over f naught here. That f naught is gonna be here. Oops. I can write letters, guys. Oops. Squared t to the 4th over r squared. Now, since this is on the bottom, we're just going to flip it. Okay. T to the 4th. So this crosses out, this, and this. So then we're left with our radius of Jupiter squared over the sun. Okay. And here we can calculate what we have. So we have 71.5 times 10 to the 6 meters squared, and 7 times 10 to the 8th meters squared. You put that into your calculator, and we get 104 times 10 to the negative 4th, or that would be 0.0104. Okay, and if you times that by 100%, you need the luminosity, it's 1.04%. Okay, and so what that means is the fractional. So that means that the fractional decrease in the brightness of the sun is just about 1%. Okay, thank you guys.